Welcome to my video on the nature of comets. Comets have been seen since the earliest times in recorded history. We have observations that go back to the 2nd century BC, and for the first 2,000 years they were really very scary things for ancient people. They would streak across the sky and they didn't know what they were exactly about. Now we're starting to understand them as ancient bodies from the edge of the solar system that give us information about the early history of the solar system. So we've gained a lot of knowledge. So what really is a comet? The idea came back in the 1950s that it's really just a dirty snowball made of ice, rock, and dust. And it's got a central nucleus here. That is where all the solid material's at, and then it forms a dust tail or a gas tail. That's where the ices sublimate. That's going from the solid to the gaseous form and form these long tails that stretch out for millions of kilometers or miles. And that's what we see in the night sky. The comets are made up of, the nucleus is the central portion. This is just the rocky, icy, dusty area that's only a few kilometers across. And around it is what's called a coma. This is where the gas is escaping. And the dust particles are just shooting out of jets from the comet as it warms up, as it gets near the sun. And it emits two types of material. One is non-ionized, just kind of a dust type material. And that stretches out and forms what's called the dust tail, which can go tens of millions of kilometers. And then we have the ion tail, which are ionized particles, and they're going to point directly away from the sun. This is the plasma tail, ion tail, gas tail, has different names. And then we see the hydrogen envelope, which is just more gas surrounding the comet. Now, as the comet orbits the sun, it really gets right around the sun when it gets the heat. When it's out in deep space, it's just a rock. And you can see the difference between the gas tail or the ion or the plasma tail, which points directly to the sun all the time, and then the dust tail, which are just dust particles that follow along behind the comet, and they kind of give the big streak across the sky. That's probably the most dramatic part of seeing a comet, is the dust tail. So where do comets come from? They really come from two different origins. One is the Kuiper belt, which is just beyond the orbit of Neptune. It's in the plane of the ecliptic, and that's when we see a lot of the shorter periodic comets that come through will come from that belt. And then the second comes from this giant ball of gas and dust and rock that surrounds the whole solar system, that stretches out almost, well, part way to the nearest star. And then this is just rock and dust, and then occasionally they will get nudged in gravitationally to come into the Earth, and these form these long period comets. So from the short period comets, which are defined as comets less than 200 years, that's an arbitrary number, but they were going to be coming from the Kuiper belt, which is in our solar system. These long period comets that we will only see once in our lifetime, come from this Oort cloud that surrounds the whole solar system. It's a big sphere of gas, dust, rock, and all kinds of debris from the early formation of the solar system. They will come streaking in as they're nudged by a passing star and go around the sun. So those are the long period comets with periods greater than 200 years. Halley's Comet is probably the most famous comet most people have heard about. That comes about every 76 years. Edmund Halley, back in the 1705, published a book stating about, he had examined the comets that had gone back the last couple hundred years and figured out they had a periodic nature to them. And so some comets are periodic. That means they return on a regular basis. Halley's Comet, 76 years. 1986 was the last observation of that. So 76 years from 86, we will see it again. I probably won't be alive. And comets have been observed for millennia. This one goes back to 240 BC, I think was the first recorded observation of Comet Halley. So why do we bother studying comets? Well, this gives us information about the early formation of our solar system. These are rocks that go back from the earliest of days. They tell us how the solar system was formed, or give us some information about the material involved. And they may also have been responsible for depositing large quantities of water and organic material on the Earth due to the formation of life. Now, there's been several spacecraft missions to comets starting in 1985, and one that was probably one of the more interesting ones was the Giotto mission by the European Space Union, and that was sent up, and it took a close-up picture a few hundred kilometers away from Comet Halley, and here we can see the solid core, the nucleus, and then the coma surrounding it. And so that gave us an idea really what's going on inside of a comet. And there's been several other missions over the last, up until fairly recently. One that I've always thought was pretty neat is the Deep Impactor. It's basically they crashed a rock or a satellite into a Comet Tempel 1 in 2005, and recorded it just right up till impact. And then they took from the satellite and other ground-based observations, recorded what happened, all the debris that was ejected. So you can see here it goes right up into it. It's got a cratered surface. It looks like a big rock. That was a pretty interesting mission. A lot of good information came out of that. So in conclusion, comets are ancient messengers of the solar system. They tell us about the past, about planet formation, the formation of the solar system. And so next time you see a comet, which there's going to be one that's going to occur here in the near future, there always is. And if you see it, hopefully it'll be bright enough to see with the naked eye. And remember that that's a cosmic story. That's telling us about our past.